Okay, back to my high school students for a couple of videos. So, in transformation units, and so what is a transformation? A transformation is anything that takes a shape and changes its size, position, or orientation. Now, for us, we look, at least for this unit, we look at what's called isometry. And isometry is just ones that change the position but don't change the size rather. So basically, an isometry is any transformation that doesn't change the size. So basically, it doesn't make it bigger or smaller. What is a mathematical reflection? A mathematical reflection is basically something that causes an object to flip over a line. That's what we're going to do with our mathematical reflections. Now, a preimage is an object prior to transformation. Let's spell that correctly. Us math teachers in our spelling. And an image is the object after the transformation. Okay, so that's some more basic definitions that we're talking about. So we got transformation, mathematical reflection, preimage, and image. So let's look at some reflections. See, I've already got some points already set out. We're going to look at, I'm going to label these real fast. A, B, C. A is 2, 3. B is 7, 5. And C is 3, 8. So what we're going to do is we're going to reflect them over specific things. One's going to be the x-axis, one's going to be the y-axis, and one's going to be the y equals x line. And there's going to be certain rules that we see take place for each of these. So let's see here. We'll reflect over the x-axis. Now this is the x-axis here. I'm going to end up with these points. Now normally I would take like a mirror and I would reflect it over, but I don't really have the ability to use the mirror right now. So let's see. These would be the points if I reflect them over. And so this would be the reflection of my triangle. And so if I look at this, now one of the things you need to point out here is that, first off, this is the preimage. Because this is the object before it reflects, and this is the image. It's the object after it reflects. And you can tell because the image will have what's called prime points. These prime points are just the A, B, and C again, but with the prime there. So you see the little, basically the little apostrophes, but they call it primes: A prime, B prime, C prime. So what's happening here is that we get 2, -3, 7, -5, and 3, -8. And so what's happening in the situation? Well, we get a rule of every time you reflect over the x-axis, you have to change the sign of the y-coordinate. Okay. So now we're going to go over the y-axis. Now you can kind of already take a guess as to what's going to happen here based on what you saw, because when we reflected over the x-axis, we changed the sign of the y. But, you know, let's just take a look anyway. So we got A, B, and C. A is 2, 3 still. B is 7, 5. And C is 3, 8. So let's see. Here's where my points are going to be at if I could actually physically reflect it over. Okay, then we end up with A prime being -2, 3. We end up with B prime being -7, 5. And we end up with C prime being -3, 8. Okay, and so what happens here? Well, the rule is we're going to change the sign of the x-coordinate. Again, this is my preimage, and this is my image. Okay. So, reflect over the x-axis, you change the sign of the y. Reflect over the y, you change the sign of the x. Okay, well, we got one more transformation here, and that is reflecting over the y equals x line. So if I reflect over the y equals x line, what's going to happen? Well, the y equals x line is really just a diagonal line going through points like 1, 1, 2, 2, 3, 3, 4, 4, etc., etc., etc. So once again, we're going to get A, B, C. So A is 2, 3. B is 7, 5. And C is 3, 8. Okay? So then what I'm going to do is I would reflect, like I said, usually I would use a mirror to do this. What it's going to come out to be is, let's see. It's going to look something like this. Okay, and what happens is that all they do is switch positions. So basically x becomes y, y becomes x. So the rule is switch positions. Okay. Alright, so let's recap. That was easy. I'm joking. Bad joke sides. We're going to have 3 rules. When you reflect over the x-axis, you change the sign of the y-coordinate. When you reflect over the y-axis, you change the sign of the x-coordinate. And when you reflect over the y equals x line, you switch positions. So if I go x-axis, and I go ahead and use the points I have here, I'm going to change 4, 5 into 4, negative 5. I'm going to change negative 4, 6, and negative 4, negative 6. I'm going to change negative 4, negative 5, and then negative 4, positive 5. And I'm going to change 0, 10 to 0, negative 10. If I decide to go over the y-axis, well, same points as above. I'm not going back to these. I'm going to change 4, 5, and then negative 4, positive 5. I'm going to change negative 4, 6 into 4, 6. I'm going to change negative 4, 5, negative 5 into 4, negative 5. And then 0, 10 is not going to change at all because 0 has no sign. 0 is neither positive nor negative, so you can't change it the other way around. Finally, if I go over the y equals x line, all I do is I flip around. So 4, 5 becomes 5, 4. 6, or negative 4, 6 becomes 6, negative 4. Negative 5, negative 4. Or negative 4, negative 5 becomes negative 5, negative 4. And then 0, 10 becomes 10, 0. Again, I went back to those same points every single time. All right. That's it. That's reflections.